Je veux le bifton, pas de bobo.
Assalamualaikum and hello everyone. So for today, we are going to begin our discussion on first order differential equation. So before we start, let's introduce ourselves. My name is Aini Safar binti Hamizan.
My name is Nur Syahira Izzati binti Muhammad Subaweh.
My name is Muhammad Amin Ashid bin Taslim.
My name is Muhammad Akmal Farahi bin Muhammad Nasir.
So before we begin with, I will elaborate a bit about differential equation that I know, based on what I know. So a differential equation is an equation involving one or more derivatives of an unknown function. Atau dalam kata lain dia, derivative ni is the rate of change of a function at a point or generally biasa saja. Okay, and kenapa topik ni panggil first order? Correct me if I'm wrong, but because of dia punya highest degree dia is equals to 1. Kan?
Yes.
Okay,
Betul,
lepas tu, there are two types of solution for differential equation, which are general solution and a particular solution. And there are two methods that can be used in problem solving on regarding this method is separation of variables method, and second is the integrating factors method. So what are the applications that we can use based on differential equation?
We now move into one of the main application of differential equations, both in this class and in general. So modeling is the process of writing a differential equation to describe a physical situation. Almost all of the differential equation that we will use in our job for the engineers out there in the audience, there because somebody at some time modeled a situation to come up with the differential equation that we are using. So we are going to introduce you the process of modeling and show you what is involved in modeling tank.
Okay, so let's get started. In these problems, we will start with a substance that is dissolved in liquid. Liquid will be entering and leaving a holding tank. The liquid entering the tank may or may not contain more of the substance dissolved in it. Liquid leaving the tank will of course contain the substance dissolved in it. If Qt give the amount of the substance dissolved in the liquid in the tank at any time T, we want to develop a differential equation that when solved will give us an expression of Qt.
Note as well that in many situations, we can think of air as a liquid for the purposes of these kinds of discussions, and so we don't actually need to have an actual liquid, but could instead use air as the liquid.
Yes, so the main assumption that we will be using here is that the concentration of the substance in the liquid is uniform throughout the tank. Clearly, this will not be the case, but if we allow the concentration to vary depending on the location in the tank, the problem becomes very difficult and will involve partial differential equation, which is not the focus on this course.
We will need to solve to get Qt. We will need the flow rate of the water entering. We have got that. The concentration of the salt in the water entering. We have got that. The flow rate of the water leaving. We have got that. And the concentration of the salt in the water exiting. We don't have this yet. So we first need to determine the concentration of the salt in the water exiting the tank. Since we are assuming a uniform concentration of salt in the tank, the concentration at any point in the tank and hence in the water exiting is given by concentration equal amount of salt in the tank at any time per volume of water in the tank at any time.
So from how do we apply the differential equation is from a real problem, we will extract into a mathematical model, which is in this situation is the modeling tank itself, and solve them by using a mathematical solution by using a differential equation. And lastly, we will interpret into real world solution. Am I right?
Yes.
Yes, I
Yes,
totally
yes.
agree with that.
So mainly the differential equation is used in a field such as physics, engineering, biology, and so on. So based on our discussion, the differential equation is suitable because it describes various exponential growth and decays. And also we can, I think, one of the great things because of like we can use it in businesses as well by describing the change in return of investment over time. And they're mentioned that the equation itself, the differential equation, are used in medical field, such as in medical field science, for modeling cancer growth of or the spread of the disease in the body. So we basically use it to apply how rapidly the cancer develops or growth in our body. And I think with that, I think this is the end of our discussion. And thank you for everyone for your information and your knowledge given by all of you. I think that's it. Thank you.
Thank you.
All right, thank you.
Ooh,